Hello guys, welcome to the geography lectures. In this lecture, I will explain about the interior structure of the earth. Why we have to know and understand and study the interior structure of the earth? Because earth was the only planet where life existed. Earth was the only planet where life was supported. Due to the internal processes, it paved a path for the origin of life in the oceans as a single-celled living organism. Second point is to understand the geological formations like formation of oceans, formation of continents, mountains, islands. To understand each and every geological formation, we have to understand the interior structure of the earth. Due to the internal forces, these structures were formed. The third one is geomagnetism. To understand the geomagnetism of the earth, we have to know what is internal structure of the earth. I will tell about the geomagnetism in the separate chapter, don't worry. And to minimize the risk from the earthquakes, volcanoes, or the natural disasters, we have to know about the interior structure of the earth. Where the volcanoes existed, to know this, we have to study the interior structure of the earth. Where the earthquake were spread or where the earthquakes were generated. To understand this, we have to know the interior structure of the earth. And it is practically impossible to go deep inside the earth because the depth of the earth or radius of the earth is about 6,400 kilometers. 6,400 kilometers, and diameter is approximately 13,000 kilometers. It's practically impossible to go and dig deep inside the earth and look after the materials which were present in the earth's interior. It's practically impossible. And the second problem is the temperature rises 1 degree Celsius per every 32 meters. Temperature rises per every 32 meters. The 32 meters, the rise in temperature is about 1 degree Celsius. For every 32 meters, the temperature rises 1 degree Celsius. Okay, it's practically impossible. So some of the forces which acts interior of the earth are called endogenic forces. These forces will configure the interior structure of the earth. And we got the information about the interior of the earth. These sources are divided into direct source and indirect source. Okay, let's understand what is the direct source. Direct sources are nothing but the sources which give the information by exposing it. Okay, it gives the information, and by exposing directly, it exposes it directly to the earth's interior. Example or some of the direct sources are the deep oceanic drilling deep oceanic drilling. The largest or the deepest drill is at Kola in the Arctic Sea. The depth is about 12 kilometers, but actual radius of the earth is about 6,400 kilometers, but we dig only 12 kilometers. It is not even 1% also. And the scientists look after some drilling projects like deep oceanic drilling project and integrated oceanic drilling project, deep oceanic drilling project. These are the two projects in the ocean which the scientist will drill and see the materials inside the earth. But the problem with the drilling sources is, maybe during the process of the drilling there can be presence of rock in between. If it is the earth, they are drilling deep inside the earth, maybe there was a presence of huge hard rock, so it was impossible to dig that rock, and the temperature rises as we go deep inside the earth. The temperature rises for every 32 meters. The rise in temperature is about 1 degree Celsius. So at 48 kilometers, the temperature will be 1100 to 1200 kilometers. It can melt the drilling equipment also. It was a huge temperature. It can melt every metal, any metal. The second one is volcanic eruption. Let me show the picture. This is called volcanic eruption. By studying and analyzing the molten magma, we can able to understand the Earth's interior. Magma is nothing but it was a molten material, comes from the interior of the earth. So by studying it, we got to know the information about the Earth's interior. But the problem, by taking volcanic eruption as a direct source, is the problem studying the volcanic eruption is we don't know where the magma originated. Either it originated in the atmosphere, either it originated from the mantle, or either it originated near the border of mantle and core. We don't know. We don't know the information about it. But we got to know information is they are denser than the crust. That's it. Mining. Third one is mining. The deepest mine is in the South Africa, Johannesburg. It was a gold mine actually. The depth is about 4 kilometers. The information we got from the direct source is the outer crust. This is the outer crust is thinner than the interior of the earth. Second point, the density increases as we go deep inside the earth. And the third point is the temperature rises as we go deep inside the earth. For every 32 meters there was a rise of 1 degree Celsius. Okay. These are the direct sources which give information about the interior of the earth. What are indirect sources? Indirect sources are which we can't able to see, but it give the information about the earth's interior. Example, meteors. METEORS. Meteors, it is said that they are made and designed like the earth. And when we study these meteors, when we study these meteors, the core is made up of the denser materials. So we got to know the information is Earth core is also made up of the denser materials. And the second one is density studies. The average density of the Earth is about 5.5 gram per centimeter cube. But the crustal, only crustal, the crustal level, the density is 2.7 to 3.0 gram per centimeter cube. Why there was a large difference in the density? The entire density of the Earth is about 5.5, but you are saying the crust density is 2.7 to 3.0 gram per centimeter cube. It's not 32.3.0. Is because of the core density is about 13 gram per centimeter cube. Why? Because at the core there was presence of highly tensile substances or highly tensile materials like nickel and ferrous. Okay, during the process of evolutionism of the or origin and evolution of the Earth was segregated into different form of layers in terms of density. Higher, denser substances will go deep inside the Earth. Lesser density substances will come out. Okay, higher density elements will sink, like nickel and ferrous will sink deep inside the Earth. The lighter elements like silica will come out. Next, third one is by studying temperature and pressure studies. Temperature and pressure studies. As I said, the temperature rises for 32 kilometers. There was a rise of 1 degree Celsius. It was only at the crustal level. It was only at the crustal level. Show the picture. This is the crust. This was only at the crustal level. This was only at the crustal level. Why the temperature rises at the crustal level? Because presence of radioactive materials. At 48 kilometers depth, the temperature is about 1100 to 1200 degrees Celsius. It can melt. It can melt. It can melt. I said in the drilling projects, it can melt the drilling equipments. That much the temperature is. If we take this strata for the every 32 meters there was a rise of 1 degree Celsius. If we take this strata for the whole Earth, the core temperature will be 2 lakh, approximately 2 lakh degrees Celsius, but practically it was impossible. The core temperature is 6000 degrees Celsius. At the crustal level, the temperature rises like this because of presence of radioactive material. Remember this. And the inner core was solid in state because due to high pressure, there was a lot of pressure, there was a lot of layers, lithosphere and mantle, outer core. Due to high pressure, the melting point increases. At 6000 degrees Celsius, it can't able to melt the materials anymore. Hence, the melting point increases. It needs much temperature to melt the inner core. Okay, next, seismic studies. Seismic waves are nothing but earthquake waves. There are two types of earthquake waves: surface waves and body waves. By analyzing P and S waves, its properties, we can able to know its interior. I will take the separate chapter about the seismic waves. Don't worry. Next. Next, gravitational force. Gravitational force. What does the gravitational force means? Gravitational force is nothing but the attractive force of the earth, and earth shape is bulge. From equator to the center of the earth, the distance is higher. From the center of the earth to the poles, the distance is less. Due to this, at the poles the gravitation is very high. At the equator, the gravitation is very less. At some parts or at some latitudes, due to presence of high metallic elements, the gravitational force is very high, and this difference in gravity from place to place is known as gravity anomaly. Next, magnetic field. I said already I will take it in a separate chapter, but let's discuss this. Earth has magnetic field. By understanding the magnetic field of the earth, we got to know the information about the interior of the earth. Okay. Next, what are the interior layers of the earth? There are three layers based on the chemical division. Earth was divided into three types based on the chemical division. It was crust, mantle, core. Let's discuss the first one. Crust was above the Mohorovic discontinuity. Sorry, discontinuity spelling is wrong. Discontinuity. Crust is above the Mohorovic discontinuity, and the entire crust is 1% of the volume of the earth and 0.5% of the mass of the earth. This entire oceans, continents, the entire crust mass is just 0.5% mass of the earth, and the volume is just 1% volume of the earth. Okay, and earth crust was divided into two types. One is continental crust, another is oceanic crust. The continental crust depth is about 35 to 70 kilometers. The oceanic crust depth is about 3 to 10 kilometers, and it is very light in color. Very light in color. It was dark in color. It was darker than the continental crust, and the density of the continental crust is about 2.7 gram per centimeter cube, but the oceanic crust density is about 3.0 gram per centimeter cube. Okay. Next, let me erase this. The continental crust is very older comparing to the oceanic crust. It was very older. It is said that some of the continental crust is made when the earth was originated, but continental crust is very younger. The newest oceanic crust age is not less than 400 million years ago. It is not less than 400 million years ago, but continental crust age is very older. And it was made up of continental crust is made up of silica and aluminum. It was made up of silica and magnesium. Due to presence of magnesium, it was dark in color. Okay, example is granitic. It was granitic. It was basaltic. Due to presence of high silica content, it was acidic in nature. This also consists of silica content, but comparing to the continental crust, less silica content. It was basic in nature. I will tell about the acidic basic in rocks chapter. It was basic in nature. It was acidic in nature. This is about the crust. Crust is outermost layer. That's it. Next, discuss about the mantle. Mantle is the second-most layer. Mantle is divided into two layers: upper mantle, lower mantle. And upper mantle is divided into two layers. Upper part of the upper mantle, it was solid. This is called lower part of the lower mantle is asthenosphere. This is lower mantle. And the mantle is between Mohorovičić and Gutenberg discontinuity. I will tell the discontinuities in I will tell about the discontinuities in next slide. Due to presence of more magnesium content, the density increases. At this layer, at the crust and upper mantle boundary, the density is about 3.3 gram per centimeter cube. At this lower level, the boundary between the mantle and core, the density is about 5.5 gram per centimeter, 5.5 gram per centimeter cube. So this lot of variation is because of presence of magnesium, and it was in darker in color because presence of magnesium. Next, discuss of the core. Next, another point I had been missed. Mantle consists of 83% of the entire volume of the earth. And 68%, 68% entire mass of the earth. Mantle consists of 83% volume of the earth, and mantle is 68% mass of the earth. It was a huge layer. Let me show the picture. It was the huge layer from here to here. It was a huge layer. Next, the thickness is about 35 to 2900 kilometers. Okay, next discuss about the core. The core was made up of knife. Knife is nothing but nickel and ferrous. The density increases from 5.5 to 13.0 gram per centimeter cube, and more than 13 sometimes. In some books there is 15. We taken as 13.0 gram per centimeter cube, and it consists of 15% volume of the earth and 32.5 mass of the earth. And the depth is about 2,900 kilometers to 6,400 kilometers. And the core was divided into two types: outer core, inner core. Outer core was liquid in state. The temperature is very huge that it can melt the rocks, ice. And next point is, I said Earth has magnetic field. These magnetic field are originated from here. These magnetic fields are originated from here. And the inner core was in solid in state because due to high pressure the melting point increases, so the temperature can't able to melt those metals. Based on physical division, the Earth's interior is divided into lithosphere. Lithosphere, it was the hard rocky layer, and the depth is about 100 kilometers, and lithosphere is also called as plates. I will tell again in the plate tectonics. Actually, the lithosphere consists of oceanic crust, continental crust, upper part of the upper mantle. Upper mantle consists of, I said already, upper mantle consists of two layers. What is the picture? Upper mantle consists of two layers: upper part of the upper mantle, lower part of the upper mantle. Upper part of the upper mantle, lower part of the upper mantle. Lower part of the upper mantle is known as asthenosphere. It consists of oceanic crust, continental crust, upper part of the upper mantle. Asthenosphere. The spelling is wrong, guys. Asthenosphere. It was called the low velocity zone because the seismic waves or the earthquake waves will slow down here, and the depth is about 300 to 400 kilometers depth. And the asthenosphere was in plastic in state. Lithosphere was in solid in state. It was plastic in state. Plastic is nothing but, it was neither solid, it was neither liquid, it was in middle state. It was like plastic. And this was the zone of convections. Here there are some convections. I will tell about the convections in future lectures. And the third one is mesosphere. The rest of the lower mantle is called mesosphere. It was in solid state. Next, barysphere. The inner core and outer core both was known as barysphere. Entire core was known as barysphere. Let's discuss about the discontinuity. Two different layers are divided by a transition zone based on physical and chemical divisions. Here, let's see this picture. This is the continental crust. This is the crust. This is upper part of the upper mantle. This is the discontinuity. At this discontinuity, we saw changes in the physical character and the chemical character. These are called the discontinuities zones. There are different discontinuities. There are different discontinuities. In these discontinuity zones, the seismic waves refract or dissect and gives the information about the interior of the earth. I will tell about this point in separate chapter, earthquakes. The first discontinuity is known as Conrad discontinuity. Conrad discontinuity. The Conrad discontinuity is the discontinuity between continental crust oceanic crust. The Conrad discontinuity is between the continental crust and oceanic crust. Mohorovicic or Moho, Mohorovic, Mohorovicic or Moho discontinuity is between crust and mantle. This is the transverse crust and mantle. This is oceanic crust and continental crust. Here we saw Conrad. Here we saw Conrad. Here we saw Mohorovicic. Next, third is Repeti. Repeti spelling is wrong, guys. Repeti, R-E-P-E-T-T-I, R-E-P-E-T-T-I. Repeti discontinuity. This was between upper mantle and lower mantle. This is called repetitive discontinuity. And third one, I think fourth one. The fourth one is the discontinuity between the mantle and the core. This is outer core. It's called Gutenberg discontinuity. And the discontinuity between the outer core and inner core is called Lyman discontinuity. Okay, I will explain again, guys. Conrad is between oceanic crust and continental crust. Moho or Mohorovicic discontinuity is between crust and mantle. Repeti discontinuity is between upper mantle and lower mantle. Gutenberg discontinuity is between mantle and core. Lyman discontinuity is between outer core and inner core. And this was the class, guys. Hope you enjoy the lecture. In the next lecture I will post about the minerals and rocks. Thank you. And if you have any doubts regarding this chapter, please let me know in the comment section. Thank you.